graph tangent and all the phase shifts, cotangent, secant, cosecant. On the test, you're most responsible for tangent. The other ones I just want to show you, okay? So for tangent, you've got to make sure that you're able to do tangent. Here's how it works. If you looked on your half of your unit circle, what is the sine over the cosine, the y over x at pi over 4? What is it? It's 1, isn't it? At 0, here is 1, 0. Y over x is going to be 0. So at 0, the tangent is 0. But at pi over 2, you have 0, 1. What is y over x for 0, 1? 1 over 0 is what? What do you think, Drew? 1 over 0? Yeah, you can't have it. So at pi over 2 and negative pi over 2, we're going to have infinite. Infinite this way, infinite this way. And then you said at pi over 4, which is right in the middle, we're going to have y equal to 1. So the way I like to do it is I like to go pick your 1 and negative 1, and this is going to be right in the middle between 0 and negative pi over 2. 0 and pi over 2. And then when I sketch those, it'll be a shape that looks cubic. The problem with it not being cubic, though, is that it stops at pi over 2 and negative pi over 2. It never crosses that. Cubic can keep going wider and wider and wider. But this is the graph. And if you continued it, there'd be a block here, and then you would go for the next one, and same thing for that one. It repeats if this is negative pi over 2 to pi over 2, what would you say is the period for tangent? What would you say that period is? It's not 2 pi. Turn to your neighbor, tell him, what's negative pi over 2 to pi over 2? How far is that? Go. It's not 2 pi, it's what? Pi, yep. So when we find the period, you're going to use a new calculation. Yesterday, we did all our sine and cosines with 2 pi over b. This one's going to be pi over b, just because for tangent, a regular period is only pi. Okay? And so with that in mind, we should be able to sketch all the possible graphs. So we'll do this one. Y equal to 3 tangent 4 theta. We still have A is 3 and B is 4. Now normally we'd say period is 2 pi over 4, but here it's pi over 4 because it's just tangent. It goes from negative pi over 2 to pi over 2 normally. That's pi. So therefore we go over 4. You're going to get pi over 4. No horizontal or vertical shifts for this one. So how do you sketch something awful like this? Well, you just make your asymptotes like that. So go ahead and sketch that. Draw your beautiful tangent curve. Looks like that. And then for amplitude, notice that this goes up to infinity. This really has an amplitude to it, sine or cosine, but this does not. So the way we handle it is, remember when you went right in the middle, pi over 4, and you went up and over and you had 1? What's 1 times 3? 3. We go right in the middle between the asymptote and 0, right in the middle, go up and over. That's going to be sort of your amplitude. It's not an amplitude really, but we'll just call it that. And then you go down and over, that'll be negative 3. Amplitude is just the place where if you went the middle x up and over, that's what the number will be. Then, from here to here is said to be pi over 4. So if this is 0, what will this one be? Okay, from here to here. One asymptote, the other, it's pi over 4. So starting at 0, this is only going to make it to what? Pi over 2 or pi over 8? 8. That's half. And then this will be negative pi over 8. Now it's a period of pi over 4. That's tangent. You want to try one? You try this next one. So just like before, probably need to pick off your A's and B's. A is going to be negative 1/2. Amplitude is 1/2, but we're going to flip it. B is 1/2. The period is going to be pi, not 2 pi, but pi over 1/2. Is that pi over 2 or 2 pi? Aha, 2 pi, yeah. Okay, and then horizontal shift. Well, we have that pi over 2. Is that going to go left or right with that minus sign? To the right. So that's going to be pi over 2 to the right. And then I don't think it's going up or down anywhere. Okay, so here goes. Draw your asymptotes, make your tangent curve. That was pretty bad, tangent curve, but that's all right. Okay, then the amplitude is 1/2. So right in the middle between here and the asymptote, go up and over. Instead of 1, it's going to be 1/2. And you go down and over, it's going to be negative 1/2. This period from here over to here is supposed to be 2 pi. So if this is 0, what ends up on this asymptote? Lillian, what do you think? What will end up on this asymptote? Pi. There you go. Great. And this will be negative pi. Still has 2 pi as the whole period. And then, are we done? I wish. We got to do a couple things. We got to flip it first. I'm going to flip it right now. And then I'm going to move this to the right, pi over 2. Well, in the middle between 0 and pi is pi over 2. So it's just going to be about like that. And so that's, I went the wrong way though, didn't I? It's going to go, good point. It's going to go this way, right. The right pi over 2 is about that much. So if you want to, you can draw this at pi over 2. And this will be at 3 pi over 2. And that's tangent. So students are going to work on day 2. There's some tangents and some cosines to do. Also, a couple of these where you're going to use a combination of COCO-CC or COCO-COSI to sketch those graphs. And then we're also going to do an application problem like number 5, where you're going to sketch the graph and then kind of look at the equation to make some draw conclusions about populations of butterflies. And that's day 2 of trig graphing.